Welcome to Lovix's presentation on Helium, the world's fastest persistent key-value store and why it's such a great match when paired with Intel's Optane. When hard drives were the predominant type of persistent storage, the latency of the application and database software stacks were an insignificant contributor to the total latency. Thanks to the last several years of hardware performance and latency improvements, starting with Flash and even more so with Intel's Optane SSDs, the application database software latency has become the primary contributor to overall latency. Today, most big data is still based on Google's Big Table design that was published in 2006. At that time, a typical server only had 2 cores, a 400 GB hard drive, and 8 GB of RAM, so an approach call log structured merge was used to address needs for read-write performance, fault tolerance, and scalability. Over a decade later, commodity servers are equipped with at least 10 to 20 times more RAM and processor cores and employ multi-queue flash drives. Starting in 2013, Lovix decided to build a new key-value storage engine called Helium that was parallelized and scales across cores and I/O channels and includes an extremely compact index. Today, this KVS is the world's fastest persistent key-value store and scales even further with storage-class memory devices such as Intel's Optane. Some of the feature highlights of Helium include ACID transaction group support, indexing for fast point and range query, support for billions of objects and petabytes of data, offered as embeddable library or network server, wrappers for RocksDB, LevelDB, Memcached, use of only 12 bytes per object to index, optimized for flash persistent memory including low read-write amplification, multi-queue low-level command support, and single persistent tier or level architecture. The left pair of charts show how Helium write and read operations both scale with the number of cores, or threads, versus other leading open source alternatives such as RocksDB. The right scatter plot of cumulative update operations versus latency shows how much lower and deterministic latency is for Helium versus RocksDB when they are compared using Intel's Optane drive. Lovix has also compared a Memcached compatible version of Helium running on Optane to the community version of Memcached running in RAM and found its parallelism enables it to outperform the RAM version. The added benefit of persistence ensures immediate recovery from outages as well. To summarize, Lovix's Helium paired with Intel's Optane delivers a big data key value storage engine that results in the highest read-write performance and the lowest, most deterministic latency. It is ideal for enabling real-time persistent computing for big data.